Okay, so we are actually now done with paper one, and we getting into paper two, which is the chemistry part of physical sciences. And in this lesson, we're going to talk about hydrocarbons. As you know, and you should know, should be able to define what a hydrocarbon is. A hydrocarbon carbons can be defined as compounds that contains only carbon and hydrogen atoms. So those hydrocarbons that we're going to be talking about in this lesson is alkanes, alkenes, and alkynes, as I'm sure you are already familiar with them. So before we get actually ahead of ourselves, let us first start by defining what we mean by organic molecules. So this is also one of the definition that you should know. You should know how to define what an organic molecule is. So an organic molecules are molecules that are said to contain carbon. So if a molecule, we're gonna deal with them, has carbon atoms, we call them organic molecules. And carbon is an interesting atom because it is able to form four bonds, and the second thing is that it can form what we call a single bond. So between a carbon and a carbon, we can have a single bond or a double bond, as you're familiar, and it can even go further and form a triple bond, right? Okay, cool. So now, like I've already mentioned, that everything that I've mentioned, those alkenes, and alkynes that we spoke about are what we actually refer to as hydrocarbons, molecules that contain only hydrogen and what you call and carbon. All right. So now I've mentioned that a carbon can form single bonds. It can also form double bonds, and it can also form triple bonds. So there's also another definition that you should be familiar with. So when we talk about saturated compounds, so when it forms the single bonds between these carbon atoms, we say that it is saturated. And it's important for you to be able to know the definition of of saturated. And then when it forms these double bonds or triple bonds, we call it an unsaturated compound, right? So in this respect, you will notice that when this carbon forms the single bonds between these carbons, and we only have carbon and hydrogen, those are what we refer to as alkanes. And then when it forms those double bonds, it's what we call alkenes. So those are the functional groups. And then when it forms those triple bonds, if in the chain you find maybe a triple bond between the carbon atoms, we call them alkynes, right? So those are just a few of the most important things that you have to be able to understand, you know. And in this lesson, we actually just going to be focusing about on how do we actually name these alkanes, alkenes, as well as alkynes, right? And you'll see how we do it just now. So how do we actually now name these alkanes, alkenes, as well as alkynes? So we use what I'll refer to as a prefix as well as a suffix or a suffix, right? So how do we determine what the prefix is as well as what the suffix is? You will see now. So let us start with maybe drawing a sort of a table, and in this column, may say we have number of carbon atoms. So this number of carbon atoms in the main chain, right? And then here we'll write the prefix, and I'm sure you're already familiar with this. So we'll only go up to about eight number of carbon atoms in the main chain, about 8 carbons, 3, 4, 5, 6, 7, 8, right? And then the prefix for this, if there's one carbon, we know the prefix is going to be meth, right? If there's 2 carbons, I'm sure you know this, it's going to be eth. If there's 3, it's going to be prop. If there's 4, it's going to be but. And then if there's 5, it's going to be pent. If there's 6, it's going to be hex. And then if there is 7, so if there's 7, it's going to be hept. And then if there's 8, it's going to be oct. So that's our prefix. And now on this column we can say, okay, if it's the suffix, if it's an alkane, its suffix so the last part is going to end with ane, right? So now if it's an alkane, and the suffix is going to be ane, and then we just add your suffix, your prefix, and your suffix. So for carbon with one atom, for a molecule with one atom, we call that mev plus ane is going to give us methane. And then I'm sure you can see F plus ane is going to give us ethane. And then it continues like that: propane, butane, pentane, and this one is going to be hexane, heptane, octane. Now if it is, let me draw here, if it is an alkene, so if it is an alkene, its surface is going to be in. So meaning we're going to add our prefix, which is mev, plus our suffix, which is in, meaning we'll actually get let's see, let me just draw this quickly. I'm sure you can already see what I'm getting to, right? So we have mev plus in is going to give us methane, but then remember there's actually no such thing, and that is because here we have those double bonds. You'll see why. So we actually start with ethene, and then we have propene, then we have butane, and then here we have pentene, and then here we have hexene, and then we have heptene, and lastly we have octene. And if it's an alkyne, so there is an alkyne, the suffix is actually just going to be ine, right? So we add our prefix plus our suffix, so we actually have ethine. So these two are not there. Ethine, which is a carbon. So remember, there's only a single carbon. It cannot form a double bond with itself, right? As well as a triple bond. So that's why we don't have it. And then we have propine. And then, what is it? Butane. Pentine. And then hexine. Heptine. And lastly octine. So it's quite important for you to be able to, this is just the basics of the basics in terms of organic molecules, for you to be able to name your alkanes, alkenes, as well as alkynes, at least up to 8 carbon atoms in the main chain, right? So now we're gonna continue where we're going to talk about structural formula, molecular formula, and condensed formula, all of which you need to know how to define and also how to write down, how to draw. So now let us continue our discussion and just take, for example, alkanes. Right, let me see. Just take alkanes, for instance. And then for those alkanes, we're just going to take maybe 4 examples. So we can have methane. And then let's have what you call ethane. And then butane, propane, actually. And then butane. So I don't want to take many because the rules are just the same for all of them. It doesn't really matter. So if you know how to draw the structural formula for all of this, it's easier to draw the structural formula for longer molecules, right? Okay, so now let us we wanna draw structural formula of this. So it's important for you to know how to define what is a structural formula. So remember, a structural formula shows it's a formula that shows all the bonds and atoms in the molecule. So we show all the bonds and atoms. So for methane, we said it only has one carbon. It's a hydrocarbon, so it's connected to 4 other hydrogens. So you see, it shows all the atoms as well as the bonds. You can do the same thing for ethane. So it has 2 carbon atoms. So remember we said that carbon bonds 4 times. So it's 1, 2, 3, 4, 1, 2, 3, 4 for each carbon, and then you just draw your hydrogens there. All right, you can do the same thing for propane. And then we have hydrogen there, hydrogen there, hydrogen, 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 right? So that's the structural formula. Let's do the last one we take can be butane. Then we have hydrogen, hydrogen, hydrogen. Let's go. Okay, so now so the same thing can continue for pentane, hexane, heptane, up until I'm not sure, whatever number you like. All right. So now what we can also define what we call to be molecular formula. So what is molecular formula? Remember, all of these things are important. You need to know what is structural formula, what is a molecular formula. So in terms of molecular formula is defined as, so what does it indicate? So a molecular formula actually indicates the types of atoms and the correct number of each atom in a molecule. So let's take, for instance, methane, for example. So we know it has 1 carbon. And how many hydrogens do we have? We have 4. So its molecular formula is CH4. Ethane, it has 2 carbons, and then it has about 6 hydrogen atoms. You can count down to 3, 4, 5, 6, right? And then propane, it has 3 carbons, and it has how many hydrogen carbons? It has 8. Butane, it has 4 carbon atoms. How many hydrogen carbons does it have? It has 10. And then the same thing can just continue, right? And now we can define another thing where we talk about, what is it? Condensed formula. Let me not actually draw this line. So we talk about the condensed formula. So we have condensed formula. So what is a condensed formula? So in a condensed formula is the notation that shows the way in which atoms are bonded to each other in a formula, but it does not show all the bond lines. So here we showed all the bond lines. Here we don't actually show them, right? And you see, okay, so we'll say, okay, so for methane, it's condensed formula will just be CH4, right? For ethane, we have C, and on this carbon we have 3 hydrogens. Then we go to the second carbon where we have also 3 hydrogens. So I'm hoping you see what's done. Let's start here again. For this one we have C, we have 3 H atoms, and then on the second carbon we have C, and then we have 2 H atoms, and then on the third one we have C, and we have 3 H atoms or hydrogen atoms, right? Let's do the same thing here. For butane, we have carbon, it has 3 H atoms. The second one, carbon, this carbon has C, it has 2 H atoms. This one, C, it has 2 H atoms. And finally, the last one has C, it has 3 H atoms. So that's how you would normally draw your condensed formula. But also, if you look at, especially if you look at our molecular formula, we can also describe something that we call the general formula, right? So for the general formula, especially for alkanes, we say it's CnH2n plus 2. And you can just check this on your own. I'm not going to go into details of how you found it, but it's actually just basically looking at the number of carbon atoms as well as the number of H atoms, and coming to realize that it follows this sort of a general formula. So for example, if you have one carbon atoms, such as in methane, so then so we have, let's say N is 1 for methane, so 2 times 1 is going to give us 2, plus 2 is going to give us 4. So that's why for methane we have CH4. And then we can do the same thing if N is equals to 2, so the number of carbon atoms is 2, so we have 2 times 2, which is 4, plus 2 is equals to 6. That's why for ethane we have C2H6. So those are some of the important things that you have to know in terms of what is it, I'm thinking in terms of alkanes. So now let us move our discussion to alkenes. Okay, so now let us just move our discussion to alkenes, and I'm just going to rush through this because it's pretty much the same thing, except here we have those double bonds that we've spoken about. So for the structural formula, remember there's no methane, so we start with ethene, right? So ethene, we know because of this prefix eth, it has those two carbons. So we'll have two carbons that have a double bond between them, and then we draw the number of hydrogen atoms. H, H, H. So remember carbon bonds 4 times. So you have to count the number of bonds. It's 1, 2, 3, 4 for each atom, 1, 2, 3, 4 for each atom. So it would actually look like this. And then in terms of drawing its molecular formula, we just say we have 2 carbon atoms. The number of hydrogen atoms in this case it's 4, right? And then what about its condensed formula? We can just say, okay, it's C. There are 2 hydrogen atoms there. Can either draw the double bond if you want to, or you cannot draw it. So we have CH2. So somebody else might draw it CH2, CH2. Doesn't really matter, right? And then we just go to propene. We know it's prop, so it has 3 carbons, but then we only have a double bond in the one between the 2 carbons, right? And then we check the number of hydrogens. So 1, 2, 3, 4. And then here 1, 2, 3, so we should add another hydrogen there to make the number of bonds on this carbon to be 4. And then here 1, 2, 3, 4 carbons, right? And now let's write its molecular formula. 1, 2, 3. So there are 3 carbons. How many hydrogens? 1, 2, 3, 4, 5, 6. So it's H6. It's condensed formula, as you can see, is going to be CH. So this C has how many hydrogens? Has 2. There's a double bond. There's a CH, and then here we have a CH3, right? Okay, cool. Let us now move on to this one. Butane, it has, because of the but, we know it has 4. So we'll have a double bond maybe here, and then we'll CH, no, that's incorrect. So we have how many? 1, 2, 3. So we have another H there. And then for this one, 1, 2, 3, 4. And then so it's just always making sure that for each carbon there is at least 4 bonds, right? So let's correct the molecular formula. How many carbons do we have? We have 4. And how many hydrogens? 1, 2, 3, 4, 5, 6, 7, 8. It's 8, H8. Condensed formula, CH2. There's 2 carbon atoms, the double bond, CH, and then CH2, CH3, right? And then now we have drawn everything, we can also talk about the general formula for what is it, for alkenes. And you actually find, if you look at the molecular formula, that it's actually CnH2n. So for if n is equals to 1, it means that, okay, that can be actually, so if n is equals to 2, so like for ethene, there are 2 carbon atoms, it means that there will be 2 times 2 hydrogen atoms, which is 4. If n is equals to 3, there are 3 carbon atoms, it's going to just be 3 times 2, which is going to give us 6, right? You can check it for yourself. And now let us move our discussion to alkynes. Okay, so to kind of finish off our discussion in terms of alkenes, or alkanes, alkenes, and alkynes, let us just draw structural formulas for the first 3 alkynes, right? So we know because it's F, it has 2 carbon atoms, and then because its functional group is it's an alkyne, it has those triple bonds. So already there are 3 bonds here, it meaning you just need 1 hydrogen on this side, 1 hydrogen on this side, so that the number of bonds on each carbon can be 4. 1 2 3 4, 1 2 3 4, right? Let us draw the molecular formula. The molecular formula, how many carbons do we have? We have 2. And then how many hydrogens do we have? We also have 2, right? Then the condensed formula is just going to be CH, the triple bond CH. So it's the C with a hydrogen, the triple bond between them, as well as the C with this hydrogen over there, right? Somebody might just draw it CH, CH, right? Propane, it's 3 1 2 3. So we have 1 2 3. If you put that triple bond there, 1 2 3, we just need 1 hydrogen there. 1 2 3, need another hydrogen over there. No, I'm lying, it can be. So 1 2 3 4, and then here we'll just have those 3 hydrogen atoms, right? Okay, so now how many hydrocarbons do we have? We have 3. How many how many what is it how many thingy? So we have 3, and then how many hydrogens? We have 4, right? C3H4. And now let us go to butane. So we have 4 carbon atoms, 1 2 3. Oh, I didn't draw the condensed formula. So we then have CH, the triple bond, the C over there, and then CH3, right? Cool. And then here, just those bonds there, 1 2 3, just add another hydrogen. Here it has all of the 4 bonds. Here we need 2 hydrogen atoms, 1 2 3 4. Then here hydrogen, hydrogen, hydrogen. Okay, cool. So we have C4. There are 4 hydrogen atoms. How many? There are 4 carbon atoms. How many hydrogen atoms? 1 2 3 4 5 6. H6. Condensed formula is CH, triple bond C, C, H2, CH3. So that essentially brings us to the end, especially in terms of this discussion. But before we go, actually, I was going to forget something. The general formula. So the general formula for alkynes. So that general formula is actually just CnH2n minus 2. That wasn't in the short, I apologize. So it's CnH2n plus H2n minus 2. So n will just be the number of carbon atoms. Let's take an example with ethane. It has how many carbon atoms? It has 2. So the number of hydrogen atoms is going to be 2 times 2, which is 4. 4 minus 2 is going to give us 2. So that's why its molecular formula is C2H2. Let us check with this one. The number of carbon atoms for propane is 3. So it's going to be 2 times 3 is 6. 6 minus 2, how much is that? 6 minus 2 is going to give us 4. And you can check for all of them. So remember, all of these things apply for all of those alkanes that we've spoken about. So I'm not going to do all of them. That is your task for you to know and understand what is it that they look for. So before we go, make sure that you understand, you know how to define what is a structural formula as well as draw them. What is a molecular formula? What is a condensed formula? Additionally, what is a hydrocarbon? We've already defined what that is. What is an organic molecule? What is also the general formula for these different types of hydrocarbons, alkanes, alkenes, as well as alkynes? And also, what do we mean when we talk about a functional group? So those are some of the definitions that you might be asked for in your exam. So I don't want this video to be long, so I'm gonna cut it short. I initially I had thought that I was gonna continue, but I'll just make that to be the second lesson where we're going to talk about positional isomers as well as alkyls, right? Okay, so this brings us to the end of this lesson.